In the endless expanse of the cosmos, distances are so vast that it is almost unimaginable. It's a playground for the mind where we often find ourselves dreaming. Can we reach the farthest corners of the universe, the same way we've seen in countless science fiction stories? But what if this wasn't mere fiction? Enter the Alcubierre Drive, a concept that could turn the tides of interstellar travel and bring distant galaxies within our reach. This is a theoretical propulsion system named after the Mexican physicist Miguel Alcubierre. In 1994, he proposed an idea that felt ripped from the pages of a science fiction novel, a spaceship that could distort the very fabric of space-time, allowing it to effectively travel faster than light. But how could that be possible? Everything hinges on our understanding of space-time. Think of it like a cosmic fabric upon which we're all surfing. What if, instead of speeding up the surfer, we could create a wave that moves the surfer along with it? That's the crux of the Alcubierre Drive. By generating a bubble of space-time around the spacecraft, it contracts space ahead and expands it behind, propelling the ship faster than light could travel within normal space. But bringing this theory to life is no simple feat. It's riddled with enormous technical challenges and scientific controversies. The concept requires the existence of exotic matter with negative energy density to shape the space-time bubble. Then there's the issue of energy. The original calculations suggested it would need energy equivalent to the mass energy of the planet Jupiter. Despite these challenges, the Alcubierre Drive continues to be a compelling area of research. Scientists are exploring modifications to the original theory, like altering the shape of the warp bubble, which could potentially lower the energy requirements. There's even a project called the White-Jude Warp Field Interferometer at NASA's Johnson Space Center that aims to detect a microscopic instance of space-time warping, a tiny but groundbreaking step towards making warp drive a reality. Currently, we're using chemical rockets to propel ourselves into space. The method is effective but terribly inefficient for interstellar travel. To put things into perspective, even our fastest spacecraft, Voyager 1, would take around 70,000 years to reach the nearest star system, Alpha Centauri, using conventional propulsion. In contrast, with an Alcubierre Drive, the journey could take a matter of weeks, even days, completely transforming our interstellar capabilities. From being confined within our own solar system, we would become a species capable of spanning galaxies. Imagine the scientific breakthroughs and discoveries that could result from such an advancement. Now, let's further explore the science behind this concept. The key lies in manipulating space-time. Albert Einstein's general theory of relativity suggests that space-time isn't a passive stage on which the universe unfolds, but an active player that can be distorted by mass and energy. This distortion is what we experience as gravity. The Alcubierre Drive would theoretically create a warp bubble around a spacecraft. Inside this bubble, the craft remains stationary relative to the space immediately around it. However, by expanding space-time behind the craft and contracting it in front, the bubble itself would move, carrying the spacecraft along with it, like a surfer riding a wave. This method, fascinating as it may be, is still purely theoretical. It's important to remember that while the theory itself doesn't violate Einstein's theory of relativity, we still don't have any practical ways to manipulate space-time on such a scale. Not to mention, we don't have any evidence of the existence of exotic matter with negative energy density, an essential component of the drive's functioning. Furthermore, the energy requirement for creating a warp bubble is colossal. Originally, it was thought to require energy equivalent to the mass energy of the universe. However, with further refinements to the theory, the energy required has been brought down to merely that of a planet like Jupiter, still an astronomical amount by any standard. One notable figure in this field is Dr. Harold White, a physicist who spent years at NASA's Johnson Space Center studying advanced propulsion concepts, including the Alcubierre Drive. Dr. White proposed a variant of this concept that significantly reduced the energy requirement from the mass energy of a planet down to that of a car-sized object. It was a huge theoretical breakthrough, although it still left a significant practical barrier. Dr. White also suggested that it might be possible to generate the required negative energy using the Casimir effect, a quantum mechanical phenomenon that creates a negative pressure between two parallel plates in a vacuum. It's an exciting concept, but generating enough negative energy this way for faster-than-light travel would be a monumental challenge. Other theories revolve around manipulating dark energy, the mysterious force driving the accelerating expansion of the universe. Some estimates suggest that dark energy makes up around 68% of the total energy in the observable universe. Harnessing it could theoretically provide enough energy for a warp drive. But there's a big catch. We still know very little about dark energy and have no idea how to manipulate or control it. When discussing the Alcubierre Drive, we must also consider the potential risks and drawbacks. Hypothetically, a ship traveling at warp speed could accumulate dangerous amounts of high-energy particles, which could result in a catastrophic release of energy when the ship decelerates. Also, the craft might be unable to steer or stop once the warp bubble is formed, as it would be cut off from the external universe. Let's assume we eventually build a functioning Alcubierre Drive and can explore the universe in ways we've never done before. We'll confront a series of critical questions. Who gets to decide where we go and what we do there? What would be the environmental impact of such journeys? Would we be prepared to encounter extraterrestrial life, and how would we handle such encounters? The Outer Space Treaty of 1967, the cornerstone of international space law, states that exploration of outer space should be done to benefit all countries and that space shall be free for exploration and use by all nations, but it doesn't forbid the use of space for military activities. And it certainly doesn't address faster-than-light travel. Crafting a comprehensive legal and ethical framework for such unprecedented technology will be a challenge in itself, yet it is a critical step we must take as we advance in our space exploration endeavors. It's essential to remember that this action isn't just about traveling faster than light. It's about the possibilities that it opens up for us. With this technology, interstellar travel could become as common as international flights are today. Imagine being able to hop on a spacecraft and visit the farthest reaches of our galaxy within a human lifetime. We could directly observe phenomena that are now only theoretically known to us, like the Great Attractor, neutron stars, and more. The drive could also radically redefine our search for extraterrestrial life. Instead of waiting for decades or centuries to receive data from distant probes, we could personally visit and explore these distant worlds. From a sociological perspective, this could trigger a profound shift in how we perceive ourselves and our place in the cosmos. The vastness of space would no longer feel so intimidating, and we could truly become a spacefaring civilization. So, as we gaze at the stars, dreaming of traversing them at unthinkable speeds, remember this: today's fiction could be tomorrow's reality. It's a bold new era in space travel we're stepping into, and who knows? With the Alcubierre Drive, the line between science fiction and science fact may just start to blur. With that, we would like to thank you for joining us on this incredible journey. And as always, stay curious, keep exploring, and let's dive into the mysteries of our universe together.